everyone, it is Mr. Shark Spambot here, and in today's video, I'm going to show you how to evade antiviruses. To understand how to evade antiviruses, you need to first understand how antiviruses work. The two main ways that antiviruses detect malware are by signature detection and behavioral detection. In signature detection, the antivirus gets the signature of a file and then uses an algorithm which compares that signature with a long list of malicious signatures. And if the algorithm finds a decent amount of similarities, the antivirus will flag the file as malicious. In behavioral detection, the antivirus will monitor the behavior of a file while it is running, and will catch if the file is doing anything sus. For example, encrypting data. And if this is detected, the antivirus will stop the execution of the file and flag it as malicious. This can actually also be done in a sandbox, although most antiviruses will do this in a sandbox first, and then also monitor the file while it's actually executing on the system. So there are actually some very sophisticated ransomwares which can actually detect if they're being run in a sandbox and they will just refuse to run. And in the most part, this will also bypass signature detection. These ransomwares, because they're heavily obfuscated, and I will get to obfuscation in a second. But anyway, sometimes the antiviruses, while they're actually monitoring the ransomwares while they're actually running on the system, they're then detected, right? And then not too much data is actually encrypted, not too much of the system is harmed that way. So the easiest way to bypass antiviruses is to edit the code of the malware. So you could get some malware off of the internet, right? The raw malware, so in like the text file in whatever language it is, and if it's in a language that you actually know how to program in, then you could do stuff like change import order, change variable names, delete some code that you don't need, add some useless code, add some legit code to run on the front end. So import order, like in C, include, and then a library.h, or in Python, import random, right? And change variable name. So say there's a variable called socket. Rename that variable, and wherever that variable is being used, you need to change that as well. Delete some code that you don't need. So say there's a download and upload code in a reverse shell. You don't need the upload code. You could just delete that then. Add some useless code. So this could be like adding a print function at the beginning and end of your code. Add some like if statement, like if true equal to true, print true, and this is just useless code. Add some legit code to run on the front end. This can be like, say, you add like a video game to run in the front end, and in the background it's actually executing the malicious code. And so what you're going to do is that you're going to compile this code, and you'll actually see that if you try doing this, then the signature detection of the antivirus is not going to be as effective, because the signature of the file is going to be completely different if you change all of these things and do all of these steps. So this very effectively actually bypasses signature detection, and this was actually the whole point of the VIL framework, which was used to generate Metasploit payloads. So a little bit more complicated is to obfuscate the malware, and if you're gonna try writing your own obfuscation script and it works, that's great. It's actually not very easy to do this, but you have Metasploit encoders which do this really well, and Shelter. So what Shelter actually does is that you need to give it a PE, which is basically a legitimate 32-bit Windows executable file, and then you could actually add some what do you call it, some malicious code in there, and you could choose Metasploit. It'll actually encode that Metasploit payload, whichever one you choose. It could be reverse TCP, reverse HTTP, and I believe reverse HTTPS is also supported. But anyway, it'll take that. You just need to set the L host and L port. And then what it's going to do is that it's going to obfuscate that first and then inject that inside of the legitimate program. So say you have an Adobe installer. What's going to happen is that that Adobe installer is going to work completely fine, but at the same time, that injected malware inside is also going to run as a sub-process of the main process, which is the Adobe installer. This actually works pretty well, and it bypasses signature detection very well. But if you try this with a Metasploit payload, yes, it will bypass the signature detection, but the behavioral detection of most antiviruses will still detect it. So the best way to bypass antivirus programs is by making your own malware. Make sure your custom malware has its own unique way to bypass antivirus programs. And by the way, to do this, you do obviously need to know how to program, which is why if you're doing hacking, I highly advise you to learn how to program. Any job in IT, really, even if it's not required, which most of the time it will be, just learn how to program. It'll help you a lot. But making your own unique way to bypass antivirus programs, putting this into code is going to be very hard, and thinking of a way which hasn't been tried yet also is going to be very hard. But if you're able to accomplish this, then you will very successfully bypass AVs. So don't try what Metasploit or Empire has already done. Make something new, right? And this is really the best that you could do at this point, because behavioral detection will catch on if you use something like Metasploit or Empire, if even if it's heavily obfuscated. So make your malware mimic a legitimate program. In the case of a shell, make the connections mimic a web server connection. In the case of an information sending program, an example of this is like a keylogger. Try sending the data to your server using a GET request instead of a POST request. Now you may think, why the heck would I do this? Right, this is just going to make it more complicated. And by the way, yes, it is actually possible to send the data that you could send in a POST request, but instead using a GET request. But the reason you're doing this is because usually executable files or standalone files, they're usually going to be like an installer. And these installers are going to send GET requests to a server, so you could actually get back some certain data for certain files which need to be written for the certain program to actually work. And so these are not going to be sending post requests. This is all going to be GET request. So if you're going to be using a GET request, it's going to better bypass the behavioral detection, because it's going to look like it's just sending a bunch of GET requests. Hey, this is just a normal installer program, just getting some data. It's not like sending a bunch of your data to the server. And this is actually pretty effective and works pretty well. That'll be it to this for this video. Thank you for watching this video. If you like this video, hit that like button, and if you haven't already, make sure to subscribe to the channel.